Anijah must already be on it. Good evening, everyone. Welcome back to Workforce Wednesday. As you all know, that we've been focused on careers in biotech and maritime careers. So we're super excited that you all came back again this week, and we have another awesome guest speaker. And so I'm going to get right to it. We have Miss Cindy Lee here. She also, well, Cynthia Lee, but she goes by Cindy. So Cindy has over 20 years of experience across various biotech sectors, including nonprofit, pharma, diagnostics, and screening. Cynthia Lee has seen it all. Now, as a director of software engineering at Myriad Genetics, she is focused on using technology to improve patient care and outcomes, developing solutions that truly make a difference in people's lives. Cynthia is passionate about building inclusive, diverse teams and believes that bringing a variety of perspectives into decision making at all levels leads to better results and industry level change. She's also a strong advocate for mentoring motivated individuals, helping them grow and navigate the fast-paced world of biotech and tech. Outside of work, Cynthia is a mom of two young humans and one dog. She has a deep passion for camping, road trips, and riding roller coasters. She's by herself there. She's counting down the days until her kids are tall, excuse me, and brave. Okay. Her kids are brave, trust me. Enough to join a cross-country roller coaster adventure. Oh, she's got big dreams.
That's the dream.
Uh, she's got big dreams. She wants them to be brave enough to go on a cross-country road trip to ride roller coasters. That is so dope. But without further ado, welcome Miss Cindy. Thank you,
Hello.
Cindy. And the floor is yours. Thank you so much for volunteering your time this evening to share with us about your career and how awesome it is and all that great experience and wealth of knowledge. So thank you.
Yes, no problem. Uh, Hello. I'm actually like on a business trip right now in Ohio, and I am 5 minutes away from Kings Island, which has the US's oldest wooden coaster. And they're closed for the winter, and I'm like very upset that I cannot ride this coaster. But I like forgot about that. I was like sad, and then or I was like okay, and then you reminded me of my love for coasters, and then I reminded of that fact, and then anyways, yeah. Okay, cool. Let me try to see if I can get my deck pulled up. Is that working? I'll put it in presentation mode. Is that working? You said it's good. Okay, cool. Yeah, so thanks for inviting me to Workforce Wednesday. I'm happy to kind of chat about my career as like in software engineering. So maybe a little bit about me. I am a director of software engineering, and I currently work for a company called Myriad Genetics. And ultimately, what that kind of means is that I build software to help support operations for a genetic testing company. It is a genetic testing and precision medicine company. So we build products to kind of help with people doing genetic testing and personalized medicine. I've kind of worked 18 years in tech now, with 13 years in healthcare and only 6 years at Myriad. So that basically means like I've had a lot of software engineering experience across a lot of different industries. And I kind of bring that up because I kind of like didn't know that I wanted to do software engineering when I was like a kid. So like you hear a lot about people who like do software engineering and they're like, I knew I wanted to be a software engineer since I was like little. I was like not that kind of person. But I'm very like grateful and very like fortunate to have like found my role and to have like found this career. And actually like when I first went to college, I thought I was like dead set that I was like gonna be a journalist because I just like really like liked what that represented, like helping people and telling their stories of underrepresented communities and like giving a voice to people who like may not be heard. And so from there, I was like looking around for like internships and careers, and I decided to be a radio DJ and a camp counselor. Those seemed to be like entry level positions that were like really tuned to like my goals at that time. And it was cool, but I kind of realized I was working for a nonprofit radio station, KZSC Santa Cruz 88.1, and I was a youth leadership camp counselor. But I kind of realized like I also needed to like make some money, and so then I started looking around to be like, hey, what are the like highest paying entry level positions? And at that time, it was being a Jiffy Lube mechanic, and I had no idea how to like change oil or anything about cars. I had no passion about cars, but I was like, let's go ahead and try it. So I like applied, and there was a lot of like eyes of skepticism, like, are you sure this is what you want to do? But I was like, I'll give anything a go. And I decided to be a Jiffy Lube mechanic. That was fun. I did that for about like a year and a half. And around that time is when I started seeing my career counselor at Santa Cruz. UC Santa Cruz is where I went, and I was like, "Hey, I'm like I know I'm like passionate about a lot of things. I know I want to help people. I like really like to learn. I'm interested in STEM, but I don't really know what I want to do in my career." And she basically said, "Well, what are your goals?" And I was like, I would like as kind of like a half joke. I was like, I would like to make the most amount of money with the least amount of school. And she was like, awesome. Then have you considered software engineering? And I was like, no. And she was like, give it a go. And I was like, done. That's what my career is going to be because I don't like really want to like think about it anymore. But I just started taking engineering courses, and I thought that it was really interesting. So that was like around my Jiffy Lube mechanic experience time. And as I was kind of working there, I was like kind of going around being like, hey, I'm interested in this career. And actually, the dean of engineering at Santa Cruz walked in to get his oil changed. And I started talking to him, and I was like, hey, do you have any internship programs at your company or at the school? And he was like, we may have a couple positions opening up. Why don't you send me your resume? And actually, the first year I applied, he like downright denied me. But the second year, he was like, let me try to give you to do some AV setup in some in some I'm really old. And so that's like when they started doing um, remote classroom setups for like the first time. And so he was like, let me give you a chance to like do a little bit of IT. And I was like, sure. And then I started doing that. And then basically like, any chance I could of like learning about new technologies or like new opportunities, I would like ask if I could be put on that project. And I was like just trying to like network with like everybody at my career, like everybody in the school, and helping them with whatever came up. That's kind of where I like kind of realized that I have a knack for technology. I like really enjoy it. I like helping people solve problems with technology, and that's kind of like where I started with my career. Um, in software engineering. So then I graduated from college, and back then, if you wanted your software engineer, like if you wanted to make money, the thing that you go to is building Facebook games. And I play like a ton of mobile games, like it is my life. But I started working there. I didn't really love. Oh my gosh, this is recorded and people are gonna like judge me, but like I did not love like microtransactions and like that being the focus of um like the product launches that we were doing. And so I was like, I like really don't think that this is like the career for me. So I did that for a few years. It was good. I learned a lot, but then that's kind of where I was like, hey, I have a lot of background in biology. I mean, not a lot. I like some classes in biology. So I started seeking like different biotech industries and just kind of seeing what like entry level software positions or non software engineer. I think I did like a data entry level position as well. I started looking at like just opportunities around. And I kind of fell into a couple different roles. One was I started being a data entry analyst at one biotech. And then at another biotech, it was the Arabidopsis Information Resource Center, which is a plant genomics nonprofit that is dedicated for sequencing plant genetics. I to this day, it is like one of the best jobs that I like ever got, but a lot of it was like very focused around Your projects are like, it was a nonprofit, so it was like very defined by like what grants you get is like what you're going to do. So I was like, this is too stressful for me. Like, I don't think I want to do a nonprofit. So then I started looking around for other health tech type companies, healthcare type companies. And I worked then in 13 years in healthcare at a few different companies. And the last 6 years, I was at Myriad Genetics. And I really, really love like what we do. What we do is like building software. It got to like I guess maybe I'll like talk about my personal journey down here, but like over like all of this time, I think I learned a lot about like things that I didn't like, but I also started honing in about like what are the things that are really valuable to me. And I found out that like what I really love is like helping people and making an impact on people's lives, learning or like from people around me. Like I love listening to other people doing really interesting things and people who are like much smarter than me, like teaching me about like things that they're doing and like showcasing their skills. I really value good workplace culture. I've worked at a lot of different companies where um, there is a lot of like, this is my space, don't come near it. Like I realize like the type of company that I love to work for are like places where it's like all about sharing and all about like collaborating to build projects. I love places with a lot of intellectual challenge. And then of course, like when you're looking for a career, it's about financial stability and good work-life balance. So this is to say, like, I spent a lot of time at a lot of different types of engineering positions and non-engineering positions. And I think honing in on like just what is valuable to me and what I find are my personal values, like really helps me find a job that so far I really love and I find like very fulfilling as a director of software engineering at Myriad Genetics. Yeah, that was a long intro slide, but I'll go in a little bit about like what I do. So before I get in there, um, I thought it might be helpful to do a little bit about genetic sequencing in general and like how it works. So this is like very, very high level, but essentially what we're doing is that when we like when we sequence your DNA, what happens is we ask for a sample of your DNA. So we will send you a kit and we'll say, can you send me a copy of your, or send me some blood or send me some saliva? Um, Blood is actually like much better to sequence than saliva for a variety of reasons that I can chat about later. But those are two like main sources of genetic information. And with that, there are a lot of different sequencing methods. One of the ones that we focus on is NGS, but all of these sequencing methods, like when you break it down, what they're really trying to do is looking for genetic markers, genetic information that differs from a reference allele. So what that basically means is that we sequence your DNA, your set of reads, like what is the DNA, what is your DNA, and then we compare this against what is called a reference genome. So what a reference genome is practically is that they take a bunch of like people's DNA and then they like smash it together and they create this reference set that they call like a gold standard set. In actuality, there's like a lot of different problems with this because you'll find like some of the problems is like historically we've like mostly used like white males to like make reference genomes and throughout these days like they realize like people from different um ethnicities and people from like even different sexes like have different reference sets. So these days we actually have a lot of different sets of reference genome DNA, but overall, like what they're doing is they're comparing your DNA against a reference set. And what they can basically see is that like if your DNA is different than the reference set, then we can figure out like, does this DNA code for a particular gene? And if it's different than a particular gene, then it could potentially be nothing. Like it could be like you have a genetic anomaly and it's nothing, or it could be a sign of a genetic disorder and a disease. And so that is essentially like what is the benefit of genetic testing. So finding these like reads that are different than a reference genome, we can basically find interesting things about you. We can like study genetic disorders, which is like, oh, you have like a particular disease because your your genome is different than the reference allele, which like causes a mutation that causes a disease. We can use it to tailor personalized medicine. So we can like say, we know because you like produce this kind of protein that your genetic makeup like reacts better to this type of drug, or you may have less side effects from this type of drug. And then the third part of that is that it will also help with cancer research, which is detecting genetic mutations for cancer. So we can know both like in early diagnosis, like you're more likely to have this cancer, or like you may potentially have this cancer right now, or like you didn't have a cancer and a cancer came back. So that is kind of like what is really cool about genetic testing and what are the benefits. And then I work for a company called Myriad Genetics right now that does these kinds of really cool tests. So our company looks at really like these three kinds of we have these three business units. One is oncology, which is like, I have cancer, how should I treat it? And so there is a slew of different tests that we do. MyRisk, for example, and BRCA CDX is one that tests for breast cancer. We have a whole suite of tumor testing, which is like, I already have cancer. How is my cancer progressing? And this is like testing the genetic makeup of your blood or of your tumor or your blood or saliva. We also have our mental health unit, which is our GeneSight product, which is like, I have depression. What drugs are best suited for suiting my depression? Like back in the day, which I mean, I guess even still now, like your choice is really like, I have depression, and your doctor is like, here's a bunch of medication, just keep trial and erroring and seeing like which one is done. We kind of found that like with certain genetic markers, we can actually tell you your like your side effects. And so we can help you tailor much faster which drug is better for treating your depression and ADHD. And then personally, one that I've used for both my kids is our mental health, women's health unit, which is like people looking to start families or people who are already pregnant. Are they at risk with their family, or is their baby at risk? So, my risk we kind of already talked about is like hereditary cancer testing, which is like very important for women. But then there's also foresight, which is like are recessive disorder screening. So that's like, I'm thinking about having a child. Can you tell me my likelihood that I may be a carrier for a certain disease? Or like we can even do like me and my partner together testing if do we have a certain disease. Or we can do prequel, which is like I'm already pregnant. And what we found is there's this thing called non-invasive prenatal screening, which back in the day, you'd have to do like an amniocentesis if you wanted to sequence your DNA, which is like sticking this like very long needle in your belly and taking like a sample of the like placenta. And it's like very invasive and like obviously like people are very freaked out about it. What we can do as a screen is basically what we found is your placental DNA will shed DNA into a mom's work stream or a bloodstream and work stream, I guess. And then we can basically take blood out of like an arm, for example, and then we can separate out what is maternal DNA versus what is fetal DNA, and we can tell you the likelihood of your like child having certain diseases when you're already pregnant. So it's like much less invasive. It is like very practical. And it is something that like you could do to like help you make decisions about like your health history right now. So this is a very long intro, but actually I have one more intro slide before I like actually get into what I do. So I'll do like one more. So at Myriad Genetics, there when we start talking about like processing this lab, so there's a lot of products out here, right? Like we listed like I don't know how to go back in here, but like we listed like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like 11 products. Pretty much the life of the sample exists in the same way. Like what happens is we send you a FedEx delivery or our patient a FedEx delivery. We get their blood or saliva or tumor. We send it in, we receive it in the lab, we process it within the lab, like we basically have it go through our genetic sequencing platform. We sequence it. So now that we've like made the like what happens is like DNA turns to RNA and then you like amplify it and all this stuff. Once you do that, you like sequence your DNA, you analyze it, compare it against that reference genome, and then you perform call review, which is like now I'm like comparing this against a reference genome. Is this a right call versus is this not a right call? Then it goes through curation. So we look at that like variant that you have to see if it is actually disease causing. And if it is, then we put it on a patient report and then we send it to both you and your clinician for you guys to make a decision about like what is your next step. What I do at Myriad Genetics is I build all of the software for all of most of our products to really support these two things, the processing of the sample through the lab and this call review portion. And It's important to note that all of these teams have software teams, and I am like a very, very small piece of the puzzle. We basically write the software to support lab processing and the review portion of much of our genetic laboratory operations. Um, and one of the examples that I'll kind of give is like this video, if I can get it to work. All of this is backed, all of like our high throughput sequencing. We saw like 11 different tests. We get 1 million samples a year. There's like a ton of samples. Like, how do you process all of that? And we do that through automation. So what you'll see here is really our samples being processed. So this is like a video of the work cell that runs in our lab. You'll see a couple liquid handlers. You'll see this one doesn't have any sequencers. There's like some stamping going on. There's some like reagents being built. There's all of these like work cells that are working and like plates being transferred back and forth with this like robotic arm. All of this is really backed by software, and that is what our teams do. So we have like kind of a back to back here. So this is like what the work cell is doing, as well as what all of the software is doing connected to these work cells. So some of the things that we do here is a laboratory information management system, which tracks at a very high level, like where your sample is. Like the sample went on a plate, this plate went on this machine, some reagents got added there, it moved from one place to another. Like all of this is really important for like tracking for regulatory purposes, for making sure that like we have good quality of care, to make sure that we are delivering like a really good patient result and that we're like not messing up somewhere. Um, that being said, so that like a LIMS is very important. We also want to make sure that we have good automation. And so some of the things, some really cool software that we built is a scheduler. So what this basically does is a scheduler schedules what machines should be run. And this is like a custom application that is built within our system as well. It's called we call it GOS, G-O-S, good old scheduler. We're very good at naming here. You can kind of see like these are all of the different processes and you can see the time lapse. This is like a very sped up video of like what machine is slated to run at this time and within an hour and then 2 hours and 3 hours. And this is like how we kind of make sure that like we have a high throughput lab and a lot of things processed through the lab without our samples clashing. If you want to get a good scheduler, what you basically have to do is also code down to your instrument drivers and instrument applications. So what we've kind of learned is that like oh, the video stopped. We'll play it again. What we kind of learned is that like instrument applications kind of tend to have custom software that isn't always easily integrated into schedulers. And so what we have done is we've like stripped down each machine down to its like raw PLS like machine language, and we wrote drivers on top of our robotics to be able to control the instruments. And then we wrote an instrument app so that users can either like log into the application or programs like the scheduler can log in to basically tell the drivers what they do, what to do. And so all of this is kind of like very advanced software to be able to back up a very high throughput sequencing to deliver on all of those lab processes and products that you've seen before. And so yeah, I love watching this video. So, okay, I'll move on. Um, yeah, so this slide is kind of just like talking about what makes, like us very successful is just people doing a lot of different kinds of work. So I think it's very easy to like see that and be like, okay, technology makes it work. But there's actually a lot of different types of technologists that make it work that are part of our laboratory operations software engineering teams. Um, and there's a lot of different ways that we're sourced as well. Like there's obviously the very obvious like people who came who were like, I'm interested in software engineering. I'm going to study it. But that's actually like probably only 30% of my teams right now are like people who came from software engineering, like traditional software engineering degrees. We also kind of like, I think what's really cool about software engineering and kind of what my counselor was saying, like back when I was applying for college, is that we don't really care about like what your degrees are. It's not like you're a doctor, like you have to have certain certifications. Like being a software engineering, all we really care about is like, can you code? Like, do you like know the basics and are you able to perform the job functions? So a lot of people actually came from us from second careers. So one of the like most successful engineers that we have are people who used to work in the lab that are like, I loved doing this, but I now want a remote work from home position. I don't want to like go into my office every day. And so they learned to code in their spare time, or they went and got a secondary degree, or they went to a coding boot camp and they learned how to code. And they came as interns, sometimes as like just full-time employees. And we actually like really value those kinds of positions because they bring a lot of value that like we may not have. So we hire from like everything, like traditional software engineering degrees that don't know anything about biotech, people who are from the lab that know a lot about the lab, but then like get some software engineering experience that may not be as tech savvy, but we like find a position for them. And then we also find people who are like, I was in finance or I was like a lawyer for 10 years and I decided that's not what I wanted to do anymore. I'm like now 40 years old and I've decided to make a career change. And I've spent the last like 5 years learning how to code. And honestly, like we've had like pretty successful careers for people like that as well. Um, and so we actually like source, I think what makes teams like very successful, especially biotech companies, is like hiring people from different backgrounds to do a lot of different type of work. And what I really mean is that there are also just like a lot of different types of work to support a tech team. Like obviously there's your traditional back end full stack engineering roles, which basically means like they do all of the like Python coding and all of the database coding, all of the like super nerd stuff. But then there's also front end engineers, like people who are like, I'm not really interested in knowing a lot about the back end basics, but I know a lot about, user interfaces and user design, and I can like build things in a pretty like interface, and I can kind of help guide like what helps people like click on something, and like that's what we call like user experience. We also hire like service engineers. So all those robots that you see, like they go down sometimes and we need like help with servicing them. We also hire database engineers. That's kind of going back to like the full stack engineering. And then we also type of other specialty engineering roles. So for example, like you may be good at CRM. So like interfacing with Salesforce, which is not like only homegrown positions, but like engineering for it's called like SaaS, software as a service, like places that like already have software solutions out there, but you need to like learn how to configure them and code for them for the particular business position that you need. There's also a lot of like non-engineering roles. For example, like I talked a little bit about before being compliant. So there's like quality assurance, which is people auditing us and like helping us like learn about, the FDA and like regulations and making sure that we're like following regulations. There's also project managers, which is like people who like just help translate like this physician actually wants this, not like this whole thing that you're building, or the lab actually wants this and you're making it too complicated. And they help us like design requirements. And they're also very much part of a tech team. And so it's a big team doing the work that we do, but it is also like very exciting, just like working with a lot of different types of people to kind of build um, what I think like are pretty complicated solutions, but like I don't know, there's like a lot of people helping to like make that successful. Um, And yeah, I think that kind of summarizes it up. And then maybe my last slide here is like just kind of chatting about the best advice like I've ever received. Just kind of like talking about um, like my career journey and like what I do. Like still to this day, when I think about like my next position or like, am I happy in my position or like what I want to do next? Kind of like I like really drive towards like these three pieces of advice that I got, and I like always try to share it whenever I can. One we talked about is like staying focused on your values. These are my kids, by the way. These are my values. This is how my slide is working. Is a very last minute thing. But staying focused on your values, for me, it's like helping people. It is financial stability to be with my family. It is like all of that. Like I like think about like what are your long-term goals? It's not always career related. The second one is seeking mentorship. Like I kind of glossed over like my career journey, but most of that stuff like made me feel like very uncomfortable. Like I am not um, like a speaker. I like didn't like fall into being a radio DJ like very easily. I've never changed oil in my life. Like I got like insanely hazed when I joined the Jiffy Lube team. Like engineering is still like still today, but especially more when I started a very male dominated role. One of the things that I've learned when I first started my career was someone told me, seek a mentor in like everything that you do. Seek female mentors, like you're a female engineer, seek female mentors that are like in engineering so you can bounce ideas off of them. Seek technical mentors, like if there's an area that like you don't know very much about, like learn about that. I think you don't like always have to call them mentors, but you can like, I just kind of like keep like a Rolodex of like people that I've met and kind of like ask for advice, like actively ask for advice, I think has been something that um, not only has helped me like learn, but it has helped me open doors a little bit, but more it has just like helped me learn about like different perspectives. And so it is like the one thing that like I think it's like changed my life and I like always try to do. And then the third one is to actively set goals because your goals in your career and in your life will change over time. And so it's something that like I have to remember to do, but like every year I will like be like these are the three things that I want to achieve, both like from a professional capacity, from a like what I want to learn from my job this year. And I think that really helps guide like um finding a job that like would be fulfilling, which I was like very, very lucky to find. And so yeah, I'll end with that.
Nice. Thank you, Cindy, so much. When I say I'm geeked out just like watching, I'm like, oh, coding and this and that and genetics and genomes and referencing. And I'm like, I feel like I could go and do the job now.
Yeah.
Everybody's samples would be messed up, but hey, it's okay. I'm gonna learn on the job. But thank you so much again. Such a wealth of information. I think I really appreciate you showing the different pathways into biotech and how there are so many different things that people who are interested in can come in and do, and that it's never too late. So, like you said, if you're 40 and you're having a career change, or if you want to go learn coding and then step into this. And so I really just appreciate you showing the different entryways into the career path. And so there was one question, I know we're about 3 minutes over, and if you can give me your just brief thought on it, is how does AI play a role in what you do?
Yeah, that is a good topic and
Mhm.
one that I actually find like pretty frustrating a little bit because like kind of everybody wants to kind of jump on the AI wagon. And in healthcare, I think it's like it's something we have to be like really careful about, both like in terms of like HIPAA and the fact that we deal with like real patient data and like you don't want to kind of like have AI models train against really sensitive information. That being said, it is a really powerful technology and we've like used it in a couple different ways. Like, um, let me try to think of ones that I can say in this group. But like okay,
Mhm.
some of the partnerships that we've done is like R&D, research and development, like
Mhm.
using R&D to train on certain data sets is like something that people are like definitely looking at. One that I can definitively say is I don't know if like GitHub is like something where you use to like put in your code. There's this thing called Copilot, which is like kind of helping you double check your code, making sure you have good unit tests, helping you like recommend code. Like that has been something that like many team members have like looked around with and played with, and it's really cool. And I kind of agree with the industry that like it's going to change the world. It's going to change biotech as we know it. I do think we're in a, like in healthcare, we're in a very special position where we need to be really careful about patient data and making sure that like patient integrity is like the number one thing that we care about. And so yeah, I think there will be some challenges, but
Yeah.
yeah, it will be cool.
Definitely, definitely. Thank you, Cindy. So if we can just give our round of applause to Cindy, who is in Ohio on a work trip and still made time for us today. Such an amazing presentation. Like I could tell that you really thought through it and really made sure that you were coming on to give us the best information. And so thank you again, Cindy. As you can see, all the thank yous rolling in. And so to our Q members, tomorrow we are having staff attorney Zachary Lee on. He's going to be talking about a variety of things, but specifically record expungement. So if you know of anyone who may be in need of the service, please invite them on 5:30 tomorrow evening. Again, let's give Cindy a round of applause for all of her great, like just gems dropped. I was over here taking notes at 40. Like, what do I need to do to make sure that I'm successful, all this great financial stability and have great mentors and all the things. So thanks guys for joining in this evening. If you don't have any additional questions of Q staff, you can go ahead and log off again. Thank you for staying. I appreciate you all and have a great night.